Section 8.3, Arithmetic Series. Warm-up. Find the sum of the first 100 terms of the arithmetic sequence 3, 7, 11, and so on. In order to do this, we're going to need to know what each of the 100 terms are, so we have to go through the whole sequence and find things out. After taking that time to do that, we find out that the sum of all of those terms is 20,100. Took us quite a bit of time to do that too. I don't really know if I really want to go through all that work just to get that one little sum. But now it says find the sum of the first 101 terms of the same sequence. So I've got that sum there. I've got one more to add in, so I've got to find that 101st term. And then I go from there and I get 20,503. In order to solve these two parts of the problem, I had to first make sure that I knew either the recursive or explicit formula of this arithmetic sequence. Now, it seems like a lot to try to get through all of those terms, and especially if we're looking for 100 terms, I don't have the time to go through all that myself. So there must be an easier way to go about doing this. Well, there is. It's something we're going to deal with known as a series. A series is nothing more than the sum of a number of terms of a sequence. So any sequence you have, you take all those terms, or however many terms you want to deal with, add them all up, and that gives you the sum of the sequence. There are a couple of different types of series. There's an infinite series. An infinite series just means that there's an infinite number of terms that we're going to be adding together. There's a finite series, means that we're going to have a series with a finite number of terms. So we might just add like the first 12 terms, or in the case of the warm-up, the first 100 and the first 101 terms. What we were dealing with today are arithmetic series. As we see that word arithmetic there, it takes us back to section 1 where we dealt with arithmetic sequences. And it's actually going to be very similar here. An arithmetic series is going to deal with an arithmetic sequence because that's where we're going to get our terms. So it's a series whose terms are taken from an arithmetic sequence. Let's take a look at our first example. It says to evaluate the sum from n equals 1 to 8 of the quantity of n squared minus 1. So what we're going to do is we're going to first plug in 1 for n, so 1 squared minus 1 is 0. Then we're going to plug in 2. 2 squared minus 1 is 4 minus 1 or 3, and so on the whole way up through until we get 8. We find out what all of those terms are, 0, 3, 8, 15, 24, 35, 48, 63, and we need to add all of these together. When you add them all up, you get 196. So there's our first sum. Now as we look at the second one, we have a summation, as n goes from 1 to 8, of n squared minus 1. Here all we're doing is we're just taking the summation of the n squared, so each individual term, and then in the end we're going to subtract 1 off of that. Now we could go through here, plug all these terms in and go from there, or we could realize that the previous problem we dealt with, each term is just 1 less than what it would have been before. So if I just add 1 to each of those terms, so that's 8 terms there, add 1 8 times, and then in the end subtract 1 off of there, because that's what it says after our summation, we should just be able to add 7 to 196. And if you don't want to think about it that way, you can still find each of those terms. Each of these terms is just going to be the integers squared. So 1, 4, 9, 16, 25, 36, 49, 64. And then of course there, that 1 is outside our parentheses, so we subtract that 1 in the end, and we end up with 203. Now, the idea of series was really kind of brought about by the great Gauss. He helps us to sum this series by, he solved a problem when he was in 3rd grade. There's some information about it in your book. So if you want to learn more about it, open your book, or also just do a search on Carl Friedrich Gauss and see what it is that can be said about him. So take a little bit of time, do a little bit of research there, hit the pause button. I can wait for you. I'll be here still. Continuing on. We have a theorem that came from what Gauss found. The sum of an arithmetic series with first term a sub 1 and a constant difference d is given by the formula s sub n equals n over 2 times the quantity of a sub 1 plus a sub n. In other words, what we're looking at here is in order to find the series, or the sum of the first n terms of a sequence, we have to figure out how many terms we're dealing with, divide that by 2, and then multiply that by the sum of the first term and the last term. Another way we can rewrite that is s sub n equals n over 2 times the quantity of 2 times the first term plus n minus 1 times d. Now if you notice here, a sub n is the same as part of that formula you see here in the second one. And these formulas actually are the same, they're just working a little bit differently based on what it is that we're trying to find. In the first one, we need to know the first term and the last term, or whatever term it is we're dealing with. In the second one, we need to know the first term and the constant difference, and that will help us find what term we're looking at. So you have to be able to choose which formula to work with based on what problem we're working with and what we're trying to find. Example number 2. A packer had to fill 100 boxes identically with machine tools. The shipper filled the first box in 13 minutes, but got faster by the same amount each time as time went on. If he filled the last box in 8 minutes, what was the total time it took to fill the 100 boxes? Well, here we're dealing with an arithmetic sequence. We know that our first term is going to be 13 minutes. Our last term in this case, which is our 100th term, is 8. So we know our first term, we know our nth term, so we're going to be able to find the sum of the first 100 terms. It'll be 100 over 2 times the quantity of 13 plus 8. After simplifying this, we get 1,050. 1,050 minutes, by the way. So it took 1,050 minutes to fill all of those boxes. If you want to, you can always turn that over into hours and minutes if you want to see exactly how much time it took. Some people can't think in minutes. Example number 3. A new business decided to rank 9 employees by how well they work and pay them amounts that are in arithmetic sequence with a constant difference of $500 a year. If the total amount paid the employees is to be $250,000, what will the employees make per year? Well, the first thing we want to look at is we know that we're dealing with our 9 terms. And in this case, I'm choosing the other formula to work with because I'm looking for a first term. I know how many employees there are. I know what the constant difference is. I know what the final sum is. So I need to find this first term. So I'm going to use the second formula, 250,000 equals 9 over 2 times the quantity of 2 times the first term plus the quantity 9 minus 1 times 500. Working on simplifying that a little bit, that 9 minus 1 is 8 times 500 is 4,000. And let's carry it over to the next slide. As we go on from here, one thing I can do is I'm going to get rid of that fraction by multiplying both sides of the equation by 2 9s. That gives me 5,000 over 9 equals 2 times the first term plus 4,000. Subtract 4,000 from each side, and then divide by 2. Now when you see that, there's my first term. Now do we like seeing our first term like that? No, let's write it out in dollars. It's about $25,778. And I'm going to go with that number to work with because I don't think a few cents is going to really make much of a difference in the long run here. So I'm going to round it and keep it to this whole number. But now what I have is I've got that information, so I can plug this in. I've got my first term. I know what the constant difference is. I know how many terms there are. So I multiply that in there, and I end up realizing that the highest value, the 9th term, is $29,778. So what this tells me is that the employees will earn between $25,778 and $29,778 per year. The homework for this section begins on page 507 and goes from numbers 1 to 22.